You can build it as a cert authority. They moved over to a REST API instead of a proprietary API. Probably one of the more notable things is doing the UEFI boot so that you can run routerOS on bare metal now. So if you want to run the image on bare metal and take advantage of the drivers for 100 gig NICs and build yourself a monster server router, that's possible. Looking at shaping, cake, FQCODL, IPv6 NAT, that's NAT 6.6 that they're doing. I don't think NPT is in there. And of course, I'm a huge IPv6 proponent. We talk a lot about IPv6 NAT, not because I love NAT. I really don't. I would prefer end-to-end networking, but I'm also a realist in network engineering. There's enterprises that are going to have regulatory and organizational hurdles that are going to need some NAT. So I think it's great to have that ability to use it as a crutch to get to a better state, hopefully, and get to end-to-end networking. So I think it's important that that's in there. Layer 3 hardware acceleration on the CRS devices, which also includes CCR2Ks, MLAG, VRRP, L2TP v3. You've got another type of L2 overlay. Zero tier is in there. That was probably one of my favorite things. We love zero tier. We use it all the time. It's a great out-of-band management VPN. And the fact that it paved the way for MikroTik to put it in V7 is just fantastic. So, you can look at the list. There's tons of stuff that's going in there. There's just so much development. And I commented to somebody the other day that MikroTik's kind of really able to leverage all the things they've invested in. They had a new office. Their old office was much smaller. They couldn't fit as many developers in as they started growing. And it took several years to get through that. And then they also got kind of thrown a curveball with the Tolera architecture because the boards got kind of dead-ended and development got kind of dead-ended. So developing on Tolera got a lot harder. And so it took a while to get into the new stuff in V7. And, for as many bad things as came out of the global pandemic and the crazy, past few years we've been on, it kind of allowed MikroTik to focus on development and really getting things out there. So if there's a little bit of a silver lining in the crazy past few years we've been through, it's that, it helped accelerate routerOS version 7. And even though MikroTik does, have some of their own supply chain issues, they're still way better than what we see on mainstream network vendors. We're years on some of these vendors. Like we have some quotes for major projects where we're seeing 2-year plus timelines. So, having to wait a few weeks or months for some of the MikroTik gear is still way better than where we are in some other areas. So that's really picked up steam for MikroTik. So in talking about our hardware setup, we maintain a pretty decent routerOS version 7 hardware lab here where I'm at. And we've got some in Europe. We've got some in our data center in Denver. And we kind of keep them all over the place to be able to play with these features. But the main reason that we did this is in the past, I've been big on the CHR for labbing, which I love the CHR. The CHR is great. And when MikroTik was a software only type of vendor, the CHR made a lot of sense. There wasn't really any reason other than throughput testing to move onto the router. Now that we have ASICs and we have things that you can do and put, a drive in there, you can put a hard drive in there, NVMe drive. That's, that's great. They're cheap. They're fast. You can put that in a 2116. You can do L3 offload for IPv6 and IPv4. You can do NAT offload. You can even do firewall offload, which we'll talk about a little bit later. So there's a lot of things that you can do, and you can't really test that in the CHR. Also, from a stability standpoint, we wanted to be able to test, how is this working on designs that we're going to put out in the field? If I have all these different kind of routers and interrupt them with routerOS version 6 and Tolera stuff, what is that going to look like? And also let us do a little bit of bug hunting. We've turned in a few bugs to MikroTik recently in MPLS and in the NAT hardware offload that we've discovered as we've been doing this testing on our own. We do this for clients, things like that. So it's been helpful to have the hardware lab to do this. If you follow the stubberry51.net blog, this will not be a shocker for you. This will not be unfamiliar. This is the 100 gig development lab that we built. This is just a partial picture of it. There's actually a whole nother really like half rack to this, but this is just a few of the pieces of gear that we have in there. And you'll see the 2216s down there. I think we got the first 2216s in the US online and testing. And they're down here. We have some 100 gig stuff going through here, some 2004s down here. But the area that we're going to focus on is just 3 routers for this lab so that we could, have something to simpler to kind of test this against. And the routers that we chose were the 2116, the 2004, and it's the lighter weight 2004 with the 2 S Plus interfaces. So we took 2 of those in a 2116. and tied them all together through the switching lab that's already there. And if you take a look at this, you can see I have it grayed out. So technically they go through a couple 326 switches because in order to make our labbing more efficient, we don't always recable the lab all the time. We've got some automation that just shifts the VLANs around so that we can tie whatever routers we want together to build whatever topology we're after. So that makes things kind of nice. And so that's what it looks like as you actually lay it out physically and slightly logically. And then if you want to see what the networking bits behind it are, this is what it looks like when you start getting into protocols. The very first thing that you're going to notice is that almost all the designs we do these days are dual stack. IPv6 is such a huge part of what we do. We've done a ton of IPv6 consulting and migration lately. In fact, we did a whole webinar on IPv6 for wireless ISPs and fiber ISPs and how you migrate into that. So if you go to the IPA site, you can go check that out. It's on there. But it's important to test IPv6 because it is, slightly different. There are things about it in the way you design characteristics that make it different than IPv4. So it's important to get hands-on flight time with that and get that tested. So everything here is dual stack all the way out to the two providers that we mocked up here in the border router, all the way down to our layer 3 switch here that we've got the hardware offload on, and then our aggregation router here, which is aggregating in a variety of different customers, fiber to the home, WISP, CBRS. And one of the notes that I'm going to put out here is a lot of people that are in the MikroTik space are focused on wireless ISPs, regional ISPs, maybe data centers. So this kind of topology makes a little more sense. If you're in the enterprise space, there's still a lot of relevance for you here because a lot of these protocols, we use in the enterprise now. There was a time in large enterprise that we didn't really use BGP. It was mostly OSPF. BGP wasn't used except at the peering edge. And that's all changed with VXLAN and things like that, which MikroTik does have now. It's not interoperable with other vendors yet, but they're looking at it. So that's something that, as you look at this, if you're not in the service provider space, which is where the focus of the lab will be, there are still takeaways here for you. The other thing I'm going to point out is that we are big on separation of network functions. It's a design principle that we talk about and work on all the time. And so border, core, and aggregation functions are separated out here. So you can see that. If you want to learn more about that, there's an entire another webinar on that and a podcast and blog post on that. And you can learn about what network function separation is and what the explanation of these boxes. So you can go dig into that. So I think the best place to start in unpacking layer 3 for version 7 is starting to talk about routing route. If you haven't spent a lot of time in version 7, especially if you haven't spent it in the command line, if you've only looked at it in Winbox, you might not have discovered routing route. And routing route is very much like the master routing database that you'll find in some other vendors where you compile all of the routes that exist, all possible paths, all possible attributes, even filtered routes. They're all in there. And you can see a lot of detail about what's in there. You can see BGP communities. You can see local pref. You can see whether or not it's hardware accelerated. You can see what is the recursive next hop and what's the physical next hop that it resolves to. So there's all this information that's in routing route. So as you transition to version 7, that's the first thing to get familiar with is routing route. Now you may ask, well, what happened to IP route and IPv6 route? They're still there, and they are a more streamlined table that contributes to the fib since now we have ASICs in play, and you have a software fib as well. But those break out to compile all the routes, but they draw from routing route because routing route is a read-only database. It's not a writable database. So everything else draws from this as the table is built. It gives you some really cool detail that you can get into. So if you get familiar in the command line with combining some of these operators, like the double ampersand sign, you can say, I want to look at all the detail of routes that are BGP routes and that are in the IPv4 address family. So I can look at all these routes. This one is a candidate route. It's the best candidate, but it wasn't the best route, probably because OSPF beat it since it looks like a /32 loopback. This one is the best route that is going to one of those networks for fiber to the home or CBRS, going from the edge router to the aggregation router. And I can see on this route right here, I've got a large community, which is detail that you can get into and look at. So there's a ton of stuff in here that you can take a look at. And it also has debugging information for MikroTik. One of the more important things they did is they built the information in so that if you get a route stuck in the ASIC or you get a route stuck in the software fib and it's not clearing or it's not doing what it's supposed to, they have a quick way from a software development perspective that they can go in and figure out, okay, why didn't that route work the way it was supposed to? And so it makes it a lot easier for them to develop and improve because they built a lot more debugging capabilities into this version of RouterOS than were in the last one. So if we wanted to go look at IPv4 and IPv6 simultaneously, which can be really helpful if we're trying to look at a dual stack network, we can go into routing route and say print detail where OSPF inactive. And it's going to show you not only the v4 OSPF networks that are in there, it's going to show you the IPv6 AFI networks that are in there. And it'll show you what the route is. In this case, it's a loopback. And it'll show you the gateway and the immediate gateway. So you can see the routing recursion that's happening here, and it'll lay it all out for you. So it's incredibly helpful. So what about RIP? Well, at this point in the presentation, you've been RIP rolled. This is a meme I put out a while back on Twitter where we talked about how people won't let RIP die. And it's pretty funny. Oddly enough, RIP does have a few decent use cases. And is my audio still good, Sajin?
Yeah, you're totally good, man.
Yeah, for some reason the audio sounded like it dropped out. Okay. So anyway, RIP is not used as much. Cable networks use it, Satcom uses it. Tunnel head ends sometimes use it, but we're not going to go into it on this session just because it's not as heavily used. So we're going to skip RIP, but you can enjoy the meme and being RIP rolled. So I think we're at the end of the very first section, and we're about to get into the BGP and OSPF section. So let me get that queued up. Okay, section 2 in routing protocols. We're going to take a look at OSPF at some things that are new. We're going to look at an overview of OSPF and what it looks like in RouterOS version 7. We're going to look at BGP and what's new. And the same thing, we're going to look at BGP and an overview of what's going on in BGP. And there's a lot there. To be honest, I probably could have gone for 5 hours on this. So I had to kind of pick and choose what content to put in there so that we could fit this all into a reasonable time frame. We'll probably, as MikroTik develops more stuff, we might even go into a webinar by protocol because there's just so much in there. But we're going to hit a few of the highlights. So one of the first things that you need to go look at if you've not dug into it is looking at OSPF and looking at MikroTik's website. They've done a really good job of starting to update their roadmap of where they are, what they're implementing. And this isn't just OSPF. This is the entire routing stack. There's information in static routes and general routing. If you want to know about /31s, had some note updates that they've got it almost working, that they're, should have it soon on /31s. There's MPLS information, there's multicast information, but if there's a feature that you want and it's listed here, it means that it's on their roadmap and they're going to implement it. Now, it may not be working yet, but if it's in this list, it means that it's on the list to be built. So you can at least, take some comfort from that if your favorite protocol is not on there. If it isn't in there, something that you want, like EVPN, I would love to have EVPN or ISIS or segment routing in MikroTik. There's some forum posts that I have that we'll get some links to where I've argued for that and asked MikroTik to get into those because I think they'd be great additions. Fortunately, they have an OS now where they can make those choices to make those additions. RouterOS version 6 was very hard because a lot of the things that you needed for those protocols just didn't exist or were buggy in the kernel. And we're past that. So once the initial stabilization effort of V7 gets done and we start looking on the horizon for new features, maybe we'll see some things like that. But if you're not familiar with this, go to help.mikrotik and go to pages RouterOS routing to go check it out. And if you're wondering about config conversion automatically, there is a great guide under there on config conversion. It'll tell you exactly what converts automatically and what does not. And you can go see what those are. But for the most part, the routing config and BGP and OSPF and all that, it converts from a V6 box mostly without issue. MPLS still has a few quirks. There's a few other areas that have a few quirks, but for the most part, OSPF is good to go. And one of the other things that we're going to get that's notable is SNMP monitoring for OSPF, so that if you've got whatever your NMS is, if you want to get some details on neighbor adjacencies, churn in LSAs, whatever they pack into the MIBs for that, you're going to have the ability to put that in your monitoring system, which is, granted, nothing new. All the major vendors have had this for a long time, but it's something that they can get into a very inexpensive router now, and you can get some really detailed analytics. So that part's great. So probably the single biggest change in OSPF is that they've streamlined the configuration, that it's all under one command line. If you remember OSPF in version 6, if you wanted to configure OSPF version 2 for IPv4 or OSPF version 3 for IPv6, they were entirely separate menus that you had to go build. Now they're consolidated into a single menu, and you can go in here and build. In this case, we built an instance for IPv6 under version 3, and we built an instance for IPv4 and version 2. and you build your areas mostly like you did and tie them to the instance. So that part's not really groundbreaking. The OSPF interface template is a little bit newer take on the way that they were doing that, and the way that they're handling interfaces and networks. And we'll get into that in a second because there's a slide on that. One of the other really cool things that they added is a routing ID. This is not just for OSPF, but for all the protocols. If you go into the routing menu and go to ID, you can build basically router IDs that are master IDs for everything. BGP, RIP, LDP, OSPF. You can tie all of them to, I called mine RID main and gave it a dotted decimal ID because it's not technically an IP address, but it'll pull from the highest IP address if dynamically you leave it. And it'll do it by VRF. So if you notice I had a management VRF that I built in here, and that was something that it automatically tried to pull an address, but it'll use whatever's in the main VRF if it doesn't find anything that it wants in here. I didn't get into VRFs. That was probably another area we could go way down the rabbit hole on, but I'll say this. Everything is much more VRF aware. You can manage the router and Winbox on a VRF. You can do a lot of different things with the VRFs as far as the way that you tie it into services. I think NTP is VRF aware. There's a few other things that are VRF aware. Some things are not. I don't think the software update is VRF aware yet, so they have a little more work to do on that. But if memory serves, I think they used the Cumulus Linux a while back, contributed a true VRF to the Linux kernel. And I believe that is the construct that they're using to do this. So shout out to Cumulus Linux for that, because that helped everybody in network engineering and Linux forever. So that was great. If you look at the interface template command, this is something that is more, if you're used to Cisco and Juniper, if you're used to doing the routing process on the interface, this is a lot like where Cisco started going about 10 years ago, and they want to do the network statements on the interface. Where technically you just specify it under the interface if you're doing this in Cisco. In MikroTik in version 6, we used to have network statements in OSPF that you would put in. Now you still have the ability to do a network statement if you want to specify a very specific prefix. If you don't specify a network statement, then in IPv4, then it will just pick up whatever's there and advertise it. So there's one thing to be aware of if you're doing this in OSPF. A couple things. IPv6 loopbacks, I'm not sure if this is by design, but if you do not specify the network statement on a loopback, it will not advertise properly in OSPF. I've got to follow up on MikroTik whether or not that's a bug or that's an expected behavior, because it's not clear. But if you want to get an IPv6 loopback advertised, you've got to come in here with this network statement and actually add that there. Another behavior change that we noticed, and this is something that while we were working on a lab for a client, we noticed that if you do passive interface default in routerOS version 6, it will not form neighbor adjacencies on any of those interfaces, but it won't advertise them because you still have to take the second step of going and putting a network statement in there. However, in routerOS version 7, because everything's interface based, if you passive interface default everything, then it's going to advertise everything that's out there, even though it's not going to form an adjacency. So if you're playing around with OSPF and you like passive interface default, be mindful of the fact that you may just advertise and dump a ton of networks out that you might not want to advertise. So you may need to do some filtering or adjust, the network statements that are in the interface templates, so you know exactly what you want to advertise. So be aware of that. They've also added a new network type, point-to-point unnumbered, which is something that's existed in other vendors for a while. I mean, this is something we first used in Frame Relay way long a time ago. But if for whatever reason the network that you're building, you don't want to have to put a /30 or a /29 between two routers, and you'd rather use it as unnumbered, you have the ability to do that now. So that's something that we haven't been able to do in MikroTik before. And so it's great to be able to have point-to-point unnumbered if that is relevant for your use case. So looking at routerOS version 6 versus routerOS version 7, we've already talked about a lot of these. If you want to see some examples, there is a great document at help.mikrotik.com. If you're not familiar with the transition from the wiki, if you're used to using the wiki, you may have noticed they've started putting links, and they're starting to deprecate the wiki, where help.mikrotik.com, which is built on Confluence, is where everything is at. That's where all the docs are. It's not clear whether or not they're going to keep version 6 docs in wiki and version 7 in Confluence. But that's where most of the good stuff is these days in help.mikrotik.com. And there's this article that says moving from routerOS version 6 to version 7 with examples. So if you want to know about OSPF or BGP and you want a guide to take you through all the steps, go to MikroTik, because they've already built that guide. And this is a screenshot of it. So it shows you a version 6 config where we had everything under different instances. And then it goes into, what does this look like going into version 7? What does my config look like as I built that out? So go check this out because it's got a lot of great information. A couple notes here on this slide that I'll mention for those of you that are looking for some detailed operational information out of OSPF in version 7. Interoperability with routerOS version 6 in a version 7 router with OSPF is pretty stable as of 7.5. In the early versions of 7, there were a lot of stability issues with OSPF that they fixed a lot of that stuff, and that's all pretty buttoned up. So 7.5 and later, probably even earlier than that, was pretty solid on OSPF interop with routerOS version 6. The one issue that I think is still a problem until they get BFD developed, routerOS version 6 is going to dynamically turn on BFD, or the ability to dynamically detect BFD in a neighbor on routerOS version 6. And if you don't disable that, then it will knock OSPF down, and you'll spend forever scratching your head as to why, until you realize that BFD on the routerOS version 6 side is doing something to mess with version 7, and the neighbor just sits there and flaps all day long. So that was a fun one for us to go discover. So definitely take note of that if you're going to be doing V6 to V7 interop with OSPF, which I'm sure a lot of people are going to. So let's look at a basic config overview, and I got to see if I can zoom a little bit. Oh yeah, we can zoom. Okay, so hopefully this is big enough for you to take a look at the config that we put in this lab here. So you can see we got our little router here. We got our CCR 2004 connected in over VLAN 3100 into the core, into our layer 3 switch, which is our 2116. And we got the other 2004 over here. So if we look at some of the config here, you'll see all the constructs that I just mentioned. We have our instances for V4 and V6. We've got a backbone area. We've got area 0. And we've got the interface template built out with the 200 IPv6 loopback specified here. So this is the most basic recipe. There's a lot of other things you can do. You can get into other areas. Summarization is supposed to work well now in OSPF, where it was kind of broken in routerOS version 6. That's not a piece that I've tested yet, but it's reportedly working now, where you can summarize between areas in OSPF well. So that's great. As you move over here into the middle, it's pretty much the same config all the way down. It's very modular. Not that MikroTik wasn't already modular in its config, but in playing with OSPF and BGP in routerOS version 7, it's even more modular. It's a lot easier to rinse and repeat things in the way that they built it. So pretty similar config over here, and pretty much the same thing over here on the last router to get OSPF built all the way out. So if you've built it on routerOS version 6, you're not going to feel totally lost. So let's take a look at what do I do to validate a neighbor. And it's pretty straightforward. Routing OSPF neighbor print detail, almost identical, or probably is identical to what we used in routerOS version 6. And you can take a look at this and see the neighbors that are here, both IPv4 and IPv6. So it lists both of them. So that's a time saver. You don't have to necessarily go into OSPF version 3 versus version 2 to look at your neighbors. You can look at both in a dual stack network from the same command. So that's helpful. And then you've got a lot of information here in OSPF interfaces. So if you want to see what the OSPF interfaces are doing, whether they're dynamic, what area are they tied to, a lot of the same information that you would have in routerOS version 6, that's all there. And because everything is interface based now, it's helpful to get that detail. One of the other cool little tricks that they put into routerOS version 7 is they put some validations that if you disabled a piece of config that had a dependency, in certain parts of routerOS version 6, it would just kind of make it red and to be like, oh, this is dead. And I don't know why. It's just dead because it has some dependency that it needs. They went a step further in routerOS version 7 and said, hey, your OSPF area is not active. And if you were to go back in the lab here and go look at why this wasn't active, it was because the instance actually had a router ID that was not there. I was playing around with router IDs and deleted it. And it was pointing to a router ID that had been deleted. So the whole instance got disabled by MikroTik. And because the instance was disabled, it wouldn't bring the area active. So as you look at this, it's going to tell you immediately what's wrong. So you're going to save yourself a fair amount of time in troubleshooting on OSPF and BGP because these kind of health checks and dependency checks are built into routerOS version 7. So that's kind of a nice piece to have. You've also got 3 places to go look at routes. So if you remember, we have IP route print, we have IPv6 route print, and then we have routing route print. So you have 3 different locations that we can go look at these OSPF routes. And if I use the where operator on all of these, I can filter it down to just the OSPF routes. So I can see what my point-to-point subnets and my loopbacks look like. I can see what my point-to-point subnets and my loopbacks look like in IPv6. And then I can get a little bit more detail into here and then look at routes that are, not being offered into the routing table that are sitting here in routing routes that for whatever reason, well, a lot of times what you'll see like a connected route and an OSPF route sitting in routing routes. And so because the connected route is a better route for a subnet that's a point-to-point subnet, obviously OSPF is not going to be the best route for that on this router. But it still records the fact that it exists in OSPF and connected in routing route. So your ability to debug routing is a lot better in this. LSA detail, mostly the same format that we saw in RouterOS version 6. So you do have, all of the deep, if you want to get into the deep weeds of LSAs and understand what's inside this LSA. One of the nice things they did is they've got an IPv6 buttoned up. IPv6 was not totally finished on OSPF v3 in RouterOS version 6. It was okay. It worked, but it had a lot of gaps. And so now that IPv6 is fully supported because of the work that was done in the main Linux kernel and then MikroTik did on the routing protocols, there's a lot more that we can do in IPv6. And in fact, it's paving the way. There's a lot of things they're doing. I didn't get into MPLS on this particular session for 2 reasons. I think I saw it asked about in the chat a few times. MPLS is still a little bit of a work in progress. They're still fixing things in there because now you have IPv6 MPLS. There is LDPv6, and you can have a pure native IPv6 underlay in MPLS and then put IPv4 over it. You can put IPv6 on top of it. You can do whatever you want with it. And there's still a few things that they're working on that. So I'm going to wait maybe just a little bit longer before we do MPLS to let that bake a little more and have a few more things added. And then we'll do a deep dive just on MPLS because I think it'd be better as its own topic. But I bring all that up because so much work is being done in IPv6 that it gives us the ability to do things in IPv6 that we've never done. It would like build a single stack network, which is fantastic. So that ends the tour of OSPF of what we got into. There's certainly a lot of other things that we could have gotten into, and I think we will get into in future webinars. But this is kind of the tour of what's there and what are the things that are, I think, most important and relevant. If you look at BGP, there's a lot more in BGP that they've added. There's a ton of things that are new in BGP, and it even goes into 2 pages here of, if you look at the feature matrix of what they've added. So it's the same place as OSPF is. It's on the same page. Config conversion for BGP is pretty much flawless, works pretty well. BGP roles is a really, really neat addition. And it's interesting because MikroTik was one of the very first network vendors to have this implemented. I think they might have had it implemented even before what I saw in Juniper and Cisco, because it was published as an RFC draft in, I think it was July of 2020 by Kier Patel, who's over at Arcus. He used to work at Cisco, has got a lot of BGP patents, and he kind of led this one. Super nice guy. If you ever get to meet him, we had a chance to talk out at Networking Field Day. Genius on BGP. And he came up with this idea that if I build these predetermined filtering roles of, hey, I'm an eBGP client or customer of a transit peer, or hey, I'm a transit provider and I'm serving to a customer, or I'm an IBGP route reflector or IBGP route reflector client. So they built all of these predefined roles that you can read in the RFC. And we'll go into that in a minute because there's a slide on that, but that's pretty cool. You can be a route server now. If you want to use MikroTik as a route server for an IX, once they get all the BGP features in that you're looking for, you can use it as a route server and put some of those 2216s in, or even the x86 if you want to. And SNMP, just like we did in OSPF, SNMP monitoring for BGP is in there. So that's great because that's going to give us some advanced analytics that we don't have. So looking at the second section of this, some other things that are in here that are notable is FlowSpec. And while it doesn't strictly support FlowSpec as far as the actual protocol, it is able to forward FlowSpec attributes now. Whether or not MikroTik is going to implement BGP FlowSpec to be able to actually steer traffic and siphon traffic off from a scrubbing center to deflect a DDoS attack is unclear. It'd be great if we could. I think it'd be a great feature to have because a lot of operators are using it now. But it is something that we can at least pass the attributes on it now. A few of the other things that are in there, RTBH is not, it says it's NA, but it's gone white in these later versions. So it looks like that usually means they're working on it. If it hasn't gone green, it means it's not ready yet. BGP advertisements is one of the things that is, it's actually pretty simple. And you would think that everybody would have it, but whatever happened in the way that they wrote it, it was a bit of a struggle to get it going. So a few months ago, they put out a very kind of a hack together system with a packet capture to let you see the advertisements that you were sending out. And as luck would have it, the version that dropped today, which is 7.6 beta 8, they actually have the BGP advertisement feature as a command line where you don't have to jump through the hoops and you can actually just print the advertised network. So if you're watching this right now, you heard it here first. You can go download that and tell me what you think about it, because I haven't even had a chance to play with it yet, or I would have put it in here. So that's the second half of some of the things that they're doing in BGP. BGP multipath is another big one. If you want to be able to do multipath in eBGP, iBGP already kind of worked in routeros version 6, but in eBGP it did not, and you can ECMP with eBGP now. So that's a part that's working. That's great. I've actually tested that. That's working. I don't think they must have just forgotten to put it green there, because that's definitely working. So again, just like OSPF, if you want to get a little bit deeper into the config translation, MikroTik has a great article. Go to the same article, which is routerOS version 6 to version 7 with examples. This is just a little screenshot of it that takes you through some of the things that they did and some of the choices that they made, like templates. Just like in Cisco and Juniper and Nokia, if you want to be able to build a template that has common things that you would repeat in a peering session, you can build a template with anything that you want almost in it, and then reference that when you build the actual peering, just like you can in other vendors. So that's going to make it, if you're a transit provider or you're doing a lot of peerings in your network, that's going to make it a lot easier to do that, where it was a bit harder. So definitely go check this out. One of the things that I will bring up, it's a known issue in BGP, because iBGP does not really work over routerOS version 6 without some hacks, like setting next hop self on every single peer. If you join an iBGP domain that's been kind of hacked together like that by setting next hop self everywhere, with routerOS version 7, where recursive routing in IPv6 works properly, we have seen there's potential for some routing loops. So be very mindful if you're going to join those two together, and just be very aware of your next hops that you've set, so that you don't end up in a routing loop. Okay. Moving on, this is BGP roles. I've got a little bit more information here. You can kind of see some of the roles that are possible: eBGP, eBGP customer, eBGP peer. You can get into eBGP route server client, iBGP, iBGP RR client, and so on. So it gives you a lot of flexibility. And again, if you go read RFC 9234, it'll tell you what those default filtering actions are. And MikroTik made a note that they've not fully implemented this yet, so I don't know where the limitation is in that. But once it gets fully implemented, being able to put a quick safety net on a peer, if you say, hey, I'm a transit provider, I'm a regional ISP, and this is my downstream customer that I want to sell transit to. If I put them as an eBGP customer in that role, the ability for them to send me all of the tables from all the other providers they're peered with is minimized, because it's not going to accept that based on the rules of that role, which again, you can go read at the RFC. Doesn't mean that you don't need to filter. You absolutely do. It's just another safety net there to make sure that you're not, trying to wreck the global table. So in my opinion, it's a great feature. It's a great addition to BGP, and I'm glad that MikroTik has implemented it. So peering affinity is another one that has been talked about for a long time. I mean, this goes way, way back to, for any of you that attended MikroTik user meetings before we went into the chaos of 2020, this was talked about, the ability to balance either a peering or specific elements of a peering across multiple CPU cores, because back then the CCR 1036 and 1072 were the hot boxes to have. And so being able to balance it across multiple cores was very important. I remember, I think we were in Baltimore, which I believe was in 2018 at the US MUM. Giannis Migas was there. If you're not familiar with the MikroTik organization, he's pretty high up on their technical team. He's been around since almost day one, and spends a lot of time on the harbor side. And we always see each other at the MUMs. We've been very good friends. And he called me over, and he had routerOS version 7 in this very, very basic state, doing, I don't know, something insane like 16 full tables in 10 minutes or something like that on a CCR. So they've been working on this for a long time, the ability to do the affinity for CPU. And I picked something very, very simple. There's a bunch of different ways you can get it to set the affinity for the CPU. I just did the address family. I said, okay, I want you to look at the address family and use that for what you're going to balance. And so as I go look in routing stats process print, which gives me some data that I don't have in routerOS version 6 to see, okay, here's the memory that I'm chewing up and the processes that I'm chewing up in these different routing protocols. So if I come down here into this specific peer, I can see what memory I've consumed, and you can actually get into some analytics on the resources that's consuming, and you can see that it's balanced out across the address families here for IPv6 and IPv4. I did see some feedback that the balancing was not working perfectly. I think MikroTik is working on that. There was some chatter in the forums a few weeks ago or a month ago about not all of the affinity settings are working exactly right. So I suspect as we, get through routerOS version 7 and move out of the routerOS 7 single digits and into the 7.12 and 13 and 14, you'll start to see a lot of those things get filled in that may not be working now for stuff like that. So that's what we saw in routerOS version 6. I think the other is fair. BGP large communities is a great one to have. These are used a lot in large transit providers, CDNs, a lot of ISPs, even in the data center and enterprise space. You'll sometimes see these used because EVPN is such a big deal now. We didn't have the ability to do large communities or extended communities in routerOS version 6. So having the ability to do large communities puts you one step closer to, if your decision is, do I buy that Cisco peering router? Do I buy that Juniper MX box? Do I go take a server and make one out of Vios, which, I mean, Vios is great. I like Vios, but sometimes having a hardware box is great, having a vertically integrated solution, especially if you need something low power. So having these kinds of additions of BGP large communities and extending the BGP stack is great because it fills a lot of gaps that, the people that had expressed to MikroTik that they wanted for a long time. And one of the other things that you're going to see down here, I didn't get into a ton because it's a really complex topic and I've got blog posts on it, is MikroTik's new filtering syntax. If you've not touched MikroTik's new filtering syntax, it's a lot more programmatic in nature, which sucks for me because I'm not a coder. I haven't touched code in probably since the 90s when I was decent at it. I mostly spend my time in route switch. So getting into a syntax that was more coding based took a little bit more mental effort for me because I don't live in that world as much. If you want to deep dive on this, go to Stub Area 51. There's several articles on there. There's also some articles in MikroTik, help.mikrotik.com. And in the forums, there's a lot of articles about the community, about the filtering, so you can see what's happening here. But at a basic level, you have an if statement that is looking at a matching statement. So I've said, okay, if my destination is not exactly equals, but if it lives inside 198.1.0.0/22 and it's greater than a /22, then I want to accept that route and I want to set BGP large community for the IPv4 version of this community. So you can build these really complex actions in this new filtering syntax. So it's incredibly powerful. There's a lot of things you can do in it. The context sensitive help is not completely there. So it does take a lot more mental effort to make your way through it. So there's that side of it. So if you're new to the filtering, like I said, go check out the blog post and it's got some great examples so that you can play around with it on your own. So let's look at our config overview. There's definitely a lot more config here in BGP that we got into than we did in OSPF since we built kind of an iBGP ASN here. Couple notes here. I did use IP Architects AS, which is 1016, is our global AS. It's something new for us. We haven't really had a need to have an ASN until recently because we're not a transit provider. We have data centers, but we're not really selling anything noteworthy. We just use our stuff for our company and our labs. But as we've done more peering development and testing, we decided to get an ASN because we're going to be building transit in our US data center in Denver, the new data center that we're outfitting, which is over in Copenhagen and Denmark. And then we've also got some stuff down in South America and Argentina. So we're building kind of a global peering development lab to put MikroTik and other solutions that are commodity and white box into real production environments to get a better idea of how they work in the global table for real, rather than just doing lab testing. So that's why I used AS 1016 because it's something that we got recently. I think Canadian government returned it recently, which is why it's such a low number. Couple notes on the address space here. If you're not familiar with it, looks like a public IPv4 address. It's actually not. It's a part of the RFC 2544 testing range. I use it a lot to mock up public space because it works well to look like public space when you're dealing with an ISP that you're trying to model. The other space that I'm using is technically deprecated in IPv6. The 200::/7 space was deprecated. It's not used. It's something that there's a conversation in the IETF, myself, Ed Horley, Nick Borrelio, Chris Cummings. If you go look in the IETF, there's an RFC that we published as a draft because we felt that there needs to be a lab space in IPv6 beyond 2001 DB8 because it's just a 32. We do network mergers of ISPs where they go out and buy 50 ISPs. And so now we have like 50 or 60/32 or larger prefixes that we have to integrate into a lab. So we started using this range because it's so big, we can mock up a peering backbone across an entire country or globally if we want to, and model all the different 32s, 29s, 24s, whatever that ISP is bringing to the table. So when you get a chance, go check that out and go look at the 200 space as it was proposed in an IETF draft, because it makes it a lot easier to lab and model networks when you have more than a 32 of space. So looking into this config just a little bit, you're going to see some of the same things that you expect to see. You're going to notice that BGP template, there's no longer a peer option. You have a BGP template option to build the things that are going to be common. So I know these elements are going to be common for me. The address families, the ASN, the name, the router ID that I can set. I have my routing ID in here. Just a note, OSPF is in here because when you do a router export or a routing export, it's a lot more compact and easier to get all the information rather than running several commands. So just kind of pretend that I don't have OSPF in here. If you look at routing connection, this is the equivalent of a peer. This is everything that you want to build into a peer, including your filter chain out, which controls what you send out. And also what you're putting in. You can put an inbound peer. If you're looking for network statements, just like OSPF, they've kind of disappeared from a tab in BGP. The easiest way to do it is it's slightly unintuitive, but it does make for kind of something comparable to a prefix list if you're used to Cisco and Juniper, is if you go to the IP firewall address list, it will reference the IP and IPv6 firewall address list where you can go build whatever prefix list you want and then reference it as a network to advertise. So if you don't want to do redistribution for whatever reason that is, this is the way that you do a straight network advertisement in BGP and MikroTik, is to build that address list like a prefix list, call it in the network output network here, and then it will advertise it out. You've got your remote address, your remote ASN. One cool thing they've added in BGP is the ability to dynamically determine the remote ASN and other remote attributes, because they also have BGP listening for dynamic BGP peering sessions. I haven't played with that, but it's possible to dynamically have two routers set up their BGP peer connection on their own and determine ASN and other attributes dynamically. So that's pretty cool. And that's something I'll probably play with here soon. And you've got the equivalent in IPv6 here. All the same things that I said on here as far as filtering and network and advertisements are set on the IPv6 peer. It just references an IPv6 template. Communities are called by the filter menu, where you define your communities that you want. You give them a name, and then as you get it on your filtering syntax here, you can actually call the name of that community, and that's how you can either do a set operation or a matching operation. So in this case, I think this was taken from the Edge router. If I was in a route reflector and I wanted to do a match on a community, you can do that too by putting the matching here in the first part in the if. You could put, if BGP community is this, then do this action, drop it, match it, add to the community, rewrite the community, raise the local pref, all the things that you'd expect to be able to do when you start getting into more complex BGP operations. As you come across here, pretty similar things. The main differences you're going to see are the BGP roles are going to change slightly. So the BGP role here is that of wherever it is at in the connection, is an iBGP RR client right here. In the middle router in my CCR 2116, I've changed the role to be just a route reflector because I want this router to be my route reflector. I could also use an out of path route reflector and set that role and just set this to be a route reflector client if I wanted to. So this gives you some basic filtering, even though you haven't added it, by using the BGP roles, and they are mandatory. You have to at least pick one. There's a simple iBGP and eBGP that doesn't attempt to influence them in any way. So if you want the traditional experience of don't do anything, just select iBGP or eBGP in the role, and then it won't do any additional filtering if you don't pick something more specific. Pretty similar down here. I've got some accept statements in here where I'm actually looking at specific prefixes and accepting or rejecting here in the middle router. And then as I come over here to the aggregation router, again, I've got more filtering because I'm matching these prefixes here that I've got for my services for CBRS, fiber to the home, and WISP. I'm matching those, and I want to dump those into BGP so that I can send them to the route reflector. So I won't go too far into this because I know we've got a lot to get through still. How are we doing on time, Sajin? Where are we at?
Your standards or normal standards?
No, whatever we have.
Yeah, we're over time as of right now, so
Okay.
but
So
we're okay.
I think we're doing okay. I don't think we'll be too badly over, but I definitely want to have some time for questions. So
Yeah.
So looking at this config, it, like I said, well, the slides will go out for this. So if you want to be able to look at this more in depth, you'll be able to see these slides, see the config and how this was put together for BGP, and then start messing with filters and communities and things like that, BGP roles if you want to. Just like OSPF, same places, if you want to look at BGP routes, same places you go to. IP route print, where BGP this time. So it'll show me all my BGP routes. I've got one that's not active here because OSPF beats it. I've got my IPv6 routes, which this is new. You could not have a distance 200 iBGP route actually work in routerOS version 6. So that's a huge gap that routerOS version 7 covers. That was a limitation of the old Linux kernel of being able to do iBGP and IPv6. So that's great because there's a lot of ISPs and data centers that run iBGP ASNs. And it's helpful to be able to do it in dual stack. Routing route print, same deal. You've got all the routes that you want in there. It shows you the address families, shows you the distance, gives you a ton of information if you use the detail command. And you can use all three of these to really deep dive into your routes and see what's happening with them. If you want to look at peer validation, instead of looking at peering, it's a session. So if you remember, we used connection to define the peering. Now we're going to use session, and you have some advanced session options that you can use. You can clear the session. You can soft refresh the session. You can soft resend the session just like you could in routerOS version 6. So there's a lot of options there. The one thing that routerOS version 7 seems to do a lot better at is if you've made a change in filtering or anything on the peer in routerOS version 6 that did not always come through cleanly, sometimes you had to hard down the peer. And in this case, as long as you do a soft refresh or resend or wait for BGP to update itself, all the filter changes and things that you're going to make mostly work flawlessly, like when you're changing stuff. So you don't have to, if you're in an operational network where you've got peers that you can't knock down, you can finally kind of make changes and have some confidence that it's going to work. Now, because routerOS version 7 is still being developed and we're still trying to get to that long-term version where we say, hey, this is the long-term version and it works really well. You may still have a few more bugs in this, but they're definitely well on their way to having a version that if you're a transit provider or otherwise doing a lot of peerings, you're going to have a version that is more user-friendly for operations, I should say. So received route validation. This is a little bit different than routerOS version 6. You're going to do a routing route print, and you look for belongs to. So it will dynamically name your peering session with a shorthand of this is BGP, it's IPv6, and this is the peer that I'm talking to. And so once you put that in there, you can get a short list of received routes here that just shows you those. If you want all the details of the received routes, then you can put the detail command in here with the same action and get all of those received routes in BGP and go, dig into what the attributes are of that. So you've got a lot of options there. This is actually an outdated screen now. This is the, let me go back here, just a slide. I went one too far. This is my old screen from an old lab because I didn't have a chance to go through the PCAP to show the advertised routes, but this is kind of the hacked together version that MikroTik put out to be able to view your advertised routes. You kind of had to dig through the NLRI and the packet capture, which they dumped into a text file so you could see them. Now, if you go check out that new code that just dropped today, this is supposed to be an actual command where it will just spit out a list of the prefixes and their attributes like you would on, any normal router. So after we get done with this, I'll definitely be testing that today and see how well that works, because this temporary solution, will hopefully go away and just be something that's there under the covers. So that ends the BGP section, and we're going to get into just a few slides on layer 3 hardware offload and what we've seen, what our experiences have been, a bug that we submitted on it, and where we think that's headed with the MikroTik hardware. So we'll do that here in just a second. So we're going to look at requirements for hardware offload. There, if you're coming from the Cisco and Juniper world, it's a little bit different. The way that you have to build it is slightly different. So there's a few things that you have to adapt to in the way that you get hardware offload working. We're going to look at L3 hardware offload for IPv4 and IPv6, which IPv6 just got added. I think it was like 2 or 3 weeks ago that IPv6 unicast got added for L3 hardware offload. And I'm running that at my office now and in my home network where I've got CRSs and CCR2K routers. And that works really well. Haven't had any complaints from the user base that would otherwise notify me. Requirements for NAT and firewall offload. We actually just put this into production for a fairly large ISP over in Africa that needed to be able to build some bigger CGNAT gateways. It's still early days. We still have a lot of testing, but we were able to get the hardware assisted NAT working and in production. It originally failed. I think they had some buffer issues. We submitted a bug report after we did testing in the lab. So we'll talk about that here in a second. And then look at the general L3 firewall and NAT offload for IPv4 because it doesn't exist yet for IPv6. All right. So L3 hardware offload, here are some requirements that you need to be mindful of if you want to use this. The very first thing to note is that all your L3 configuration has to be on the bridge tied to a VLAN interface. And what I mean by that is if you use routing protocols, they're going to exist wherever they exist in the OS. That doesn't change. Where you put your IP addresses, though, and your interfaces changes if you want to be able to take advantage of the L3 hardware offload in that it all has to be on the bridge. So to give you a baseline, if you're coming from the world of Cisco, because Juniper's a little bit different, but in Cisco, you have SVIs and BVIs, which are these VLAN-based interfaces that the ASIC uses to forward traffic, whether that's inter-VLAN routing or whether that's routing, out via routing protocol to default gateway, next hop, whatever that is. MikroTik has a very similar construct in building the bridge, a VLAN interface that you put on the bridge. And then the bridge is the hardware offloaded bridge that you build. So the first thing you've got to do is go into Ethernet switching and make sure that L3 hardware offloading is turned on. It'll show you the ASIC that's in play here, which is a Marvel Prestera ASIC, which is honestly awesome. I can't say enough good things about the Marvel Prestera series. It's very inexpensive. If you're not aware of it, Cisco Meraki, it's what they use in Cisco Meraki, even though they take great pains to hide that it's Marvel Prestera inside there. Because some of the same chips that are in switches that cost like $1,500 are the exact same chip that's in a CRS 328 that costs $300. So it's great to have the same hardware and the capabilities of Marvel Prestera because there's a lot of things that you can do if they use some of the newer chips. There's even some that will hold full tables in hardware if MikroTik decides to use those. So the one we have in here on the 2116 is a pretty good chip. It allows us to do a lot of things. And if you go into the help.mikrotik.com and type in L3 hardware offload, you'll get a big long article with route table sizes for V4 and V6, a whole bunch of details on L3 hardware offload other than the summary that I have here. And you can really kind of deep dive into all the stuff there. But you do have to put it all on the bridge and then tie the VLAN interface to the bridge to make that work. LACP bonding will work, but you cannot put an L3 sub interface on your bond. So if you're used to putting VLANs as an interface under your port channel or your bonding channel with LACP and a MikroTik, it will still work, but it's going to get punted to the CPU. And if that's what you want, that's totally fine. If it's a router that you're going to use the CPU of, which in this case, the 2116 has a really beefy CPU, so it probably wouldn't hurt it at all. But if you want to take advantage of the ASIC and move it at wire speed because you want to use the CPU for something like shaping, let's say, that's where MikroTik has a really interesting proposition that doesn't exist in a lot of network vendors. I can dump all of my forwarding into the ASIC on this 2116, which it has 410 gig interfaces. So I can get 40 gig through it. I can offload all of that in V4 and V6 into hardware. And then I can use all the CPU to do complex shaping in Cake or FQCODL. So that's something that's not as easy to do in other routers because they're generally not built that way to have a really, really beefy CPU that can move a lot of traffic, like the Graviton chips in these, as well as having an ASIC that can move the traffic. They generally don't get paired together like that in other vendors. So this is an interesting way to build the router that unlocks a lot of things for you. You can only do one bridge with the member ports. If you add a second bridge that has member ports, then the first bridge that you build is the only one that will get hardware offloaded. So be aware of that you only get one bridge to do the hardware offloading. And that's the same case on layer 2 as well, not just layer 3. MPLS used to be supported in version 6 as beta. where you could be a P router. You couldn't do any NCAP as, VPLS or do any kind of label push pop or swap. But you can act as a P router. And you can literally just sit there in the middle of it and be a point in the label switch path for an MPLS network. Once they add that functionality back in, the ASICs support it. They just haven't added it back in the code. So I think we'll see that at some point. And that was another reason that I punted MPLS a little bit, because things like this are still getting buttoned up in the MPLS stack. So we'll hopefully see that later. Some of the devices will reboot the minute you set L3 hardware offload to enabled. So if you are going to enable L3 hardware offload, be very aware if you're doing it in a production router that if that router is 100 miles away, sometimes they will crash. It hasn't happened as much in the 7.5 and 7.6 series, but in earlier versions of 7. Code, you would see a complete crash of some kind when the L3 ASIC was enabled. So just be aware, you want to have some smart hands on that if you're going to do this for the first time for the protocols that you're running. And the 2116 in particular just reboots itself anyway. Again, I'm not sure if that's a bug or that's something that is intended to happen, because when you make ASIC changes in a lot of other routers, they'll force you to do a reboot because it needs to initialize the ASIC clean for the changes that you want to make. So that's it's not uncommon. Other things to note down here in looking at this is they did about a month ago, they added this submenu called L3 hardware settings when they added the IPv6 unicast capability. So being able to do fast track in hardware, IPv6 in hardware, being able to do an ICMP reply for an error in hardware was added. And then you can also do a check and see if this hardware supports fast track in hardware. And this one does. So I say all that to say, make sure you check these and make sure these are flagged on if you want to do IPv6. And I'm going to show you how to validate that here in a second. So the H flag here on our 2116 is what shows my IPv4 routes and my IPv6 routes as in hardware. And I didn't include the speed test on here, but if I take the 2004s that are on either end of this 2116, then I can push 10 gig across in a real basic UDP test using the speed test in MikroTik, using the bandwidth tool, the bandwidth tester. And, it's not a perfect test. There's other tests that are more accurate, but it's a good, easy, quick way to just see, what the box is going to do. And so with the 2116 in the middle, you'll sit at, 2-3% CPU while you're moving 10 gig or 20 gig through this box. So for a router that costs $900 and has an ASIC, it's a pretty good deal to be able to do this. If you want to understand what the route counts are in the boxes, none of them will support full tables. I think the most they top out at is something like 64,000 routes or 128,000 routes. IPv6 is obviously less because it takes up more in the way the address is formatted. Go to help.mikrotik.com, go to L3 hardware offload, just type it in search, and it'll show you what the table sizes are, not just for the routes, but as we get into firewall stuff, there are NAT entries and connection entries that are limitations that are very, very low. So if you're running a very big device, you just have to make sure that you understand that some of that will go into hardware, and MikroTik makes an attempt to determine the busiest traffic goes into hardware while the less busy traffic goes into CPU. So it tries to manage it as best it can when you get into that mode. So that's what we're going to talk briefly about, and we'll be wrapping up here shortly after this slide. The L3 firewall offload, you cannot use from our testing, which was valid as of about a week ago because we had to test this to put into prod. You cannot use VLANs. You cannot use bonding with LACP. You cannot use L3 sub interfaces, just like on the L3 forwarding. You have to have an ingress and an egress port. So you can't have them, you can't have it all on one port. So that you have one per path, so that you have an in and an out. And hardware offload has to be enabled on the master setting under the interface Ethernet switch. But here's the trick. If you want to flip it into firewall offload mode or NAT offload mode, you have to manually go disable all ports for hardware offload at the port level. So if you're not used to doing it in the command line, you have to click on all of them in Winbox, and it's a bit tedious. If you know a little bit of MikroTik scripting, you can do it pretty quickly by just doing a quick loop of all the integers of the ports and turning hardware offload off for them. Then you have to go in, and there's a specific fastpath config, and we may put it in the notes when we send this out. I didn't have it handy, so I didn't paste it in here. But there's a fastpath config they have listed on the MikroTik website that you have to go put in to go turn this on, because fastpath is how it manages taking connections that are in the connection table and pushing those down into the ASIC and into the hardware. That's the medium that manages those two things. So you have to have all of these things working to be able to get into the NAT and firewall offload. And once you've got them all working correctly, you'll get this H flag here on it, but you're also going to have a small S because you're doing source NAT. In this case, we were doing 4-to-4 NAT. And you can see that you've got a valid connection here. So if you look at the speed test that we did, I think we had iPerf 3 running on this. We put 10 gigs through. This was a 2216 that we were testing. Had we had more than 10 gigs, we probably could have put close to 100 gig line rate, which the box will do. But it doesn't have a really high connection count. So you have to use the CPU, of which the 2216 has a monster CPU. So it can move a lot of packets. And we were able to reduce this in prod by a significant amount after we worked with MikroTik to refine the implementation, and they fixed the bug. So we've seen a lot lower CPU usage in prod on this than we did before. So that's been great. But this is what it looks like when you get the firewall offload, NAT offload working. So that's it for today. There, like I said, there's 1,000 other things we could have gone into. We're going to do more of these, get into switching, queuing and shaping, firewalling, MPLS. There's a whole bunch of areas that we're going to get into, which is why we decided to break it apart like this, because it makes it easier for us to go deeper into these topics. Once BGP and OSPF are a little bit deeper and L3 harbor offload is a little bit deeper, we might even come back and do OSPF, BGP, and L3 harbor offload specific webinars to kind of get into those things. So definitely appreciate you hanging with us. I think we set a record on a webinar. I think we had 270 or 80 join at the beginning, and we've got 240, still almost, an hour and a half later, whatever it is. So, thanks for hanging with us. And we're going to open the floor up now to Sajin, who's going to probably do his best to be an FQ Coddle queue for all the questions that I see spiraling through the chat here and all the things that are out there. So we'll definitely start getting into a few of those.
Yeah, Kevin, that was awesome. Good stuff. One question that came in was regarding BFD in V6 and V7. Is that something that you're aware of? And
yes,
apparently we can't do BFD in V7.
Yeah, so BFD is one of the things that maybe is not really maybe is not well understood about BFD. And this is something that when if you were around in the dark ages of network engineering, like I was, maybe not as old as some, but I started in the mid 90s in network engineering. BFD was a really hard problem for the major network vendors to solve when they first did it. Cisco and Juniper did not have clean BFD implementations when they first started, because what happened from a coding standpoint, you're sending out this heartbeat sometimes as quickly as like 50 milliseconds, and you have this UDP heartbeat that has to go back and forth. And it got to the point where in the early days, the CPU, the control plane of the original supervisors in platforms like the Cisco 6500, it chewed up a lot of resources in the early boxes. So they finally built an ASIC for it so that you could offload BFD. And so it took MikroTik in RouterOS version 6, because I remember when it didn't work in RouterOS version 6, and I think it took 4 or 5 years to get it fixed, because when you're having to time those millisecond packets, exactly right to make sure that you tell the routing protocol, hey, there's an interruption here, or no, it's okay, I only missed, a few, I didn't miss enough to tear it down. You've got to be really precise about that. And you've also got to make sure it's interoperable with other vendors. So even though BFD seems like a really simple thing, because it's sending packets at such a high rate of speed that have to be interpreted and acted on in that very short time frame and passed to the routing protocol, it's not the easiest one in the world to get right, which is not surprising that it's been pushed back on RouterOS version 7 to make sure that it works across all the different platforms. And I think that's one of the other challenges that MikroTik is, finally starting to get a handle on. Is you look at the different board architectures, going all the way back to, MIPS, MIPS BE, and then we went into ARM, then we went into Tolera, and you have all these things that, this has to work across. And MikroTik has finally started making some strategic choices to say some of these things are just not going to work on some of these platforms, because, and I applaud them for trying to make everything work on every box. They're probably the best on the planet about not dead ending boxes after just a few years and saying, oh, you got to buy the new box. Give me $100,000 and you got to go buy the new box, and we're dead ending this box. MikroTik does not like doing that, but they recognize that there are some limitations. So things like zero tier, Wi-Fi Wave 2, things that are not going to be available in the older hardware. As the ARM64 and ARM32 boards and the Marvel Prestera ASICs, which, if memory serves, Marvel Prestera does have hardware support for BFD in the ASIC. I think that's what they're trying to finish, is getting the ASIC support and the CPU support, so that no matter which box you put it on, it's seamless. And again, you wouldn't think it, but BFD is definitely one of the harder things to get right in a network stack, if the last 20 years of Cisco and Juniper were any indication. So hopefully that shed some light on what's up with BFD. I would guess that we would see it by Q1 of 2023 is my ballpark guess, maybe sooner. But I will add to this. I'm going to put a corollary on there. A lot of people run BFD and they don't really need BFD. So if you want to fail over as quickly as possible, it's great. If that's an organizational goal of yours, it's great to have BFD. It can help you, fail over incredibly quickly. But if you need to tune down your OSPF timers to something like 1 in 4, and a 4-second gap is acceptable for you to do failover, if that's acceptable to you organizationally, you can do this with timers while you wait for BFD to get kind of vetted and implemented. So if you don't need sub-second failover in your network, don't get too hung up on BFD. I mean, if you do need it, you need it, obviously. But if you don't get too hung up on BFD when you can tune the timers down a little bit and accomplish the same objective and be relatively stable.
Yeah, that makes a lot of sense. Another good question that came up, actually, we've got a lot of different operators in this group today, everything from service providers, enterprises, a lot of data centers in here. And somebody asked a private question saying, hey, like, we've been looking at MikroTik, it's been stabilizing. And then V7 comes around and we're kind of in this new round of, oh, everything feels broken again.
Yep.
How would you kind of reframe, you being in the space for like 10, 15 years with MikroTik, how would you kind of frame MikroTik as an option for those critical networks or enterprise networks that are kind of looking for that peace of mind in vendor choice?
So there's a lot of answers that I could give to that question. So I'll take that apart in a few pieces. Leaving aside the transition to routeros version 7, oddly enough, there's a ton of enterprises that we work for that use MikroTik that I can't say because we're bound by NDA. There are a lot of enterprises that are big names in the Fortune 500 that you would immediately recognize that use MikroTik, and they just don't tell anybody. So that is definitely a thing. One of the things that's become really apparent since, we've been in this big change we've been in the world to remote working over the last few years and supply chain shortages is that enterprises have evolved. The economy is different. We're in we were in a very different economy globally than we are now and where we were entering 2020. So enterprises are looking at things very differently. Other vendors are having challenges with tax specifically. If you go into the major vendor space, there's at least one major network vendor that has prided themselves on their tax, and it is all but imploded in the last year, except for maybe a few areas. I've talked to a lot of network engineers that are, we're dependent on, 4-hour response time, getting a ticket. They have tickets going weeks and months not getting worked. So enterprises are starting to kind of change expectations in what they're doing, because if they can't get that experience from the big vendor, then they starting to question, and I've heard this over and over, why am I paying all this money for TAC if it's taking 3 months to get a ticket out? There's a major firewall vendor that's in the same boat that they just, haven't been able to keep up, and tickets are going months without getting worked. So MikroTik, comparatively, you can't pick up the phone and call them, which is kind of how we came into being. We started work for a lot of enterprises that wanted to pick up the phone and call somebody. So in addition to the service provider work that we do that for several large enterprises. The notable ones that I would put out there that have published that they're using it, Formula One Racing is using it, SpaceX is using it. If you look on their launch pads, if you look on Twitter, there's pictures of MikroTik gear on the SpaceX launch pads, which is my absolute favorite use case, because when people say, well, is it enterprise grade? Is it going to be critical? It's on a rocket launch pad, right? Like, it doesn't get any more critical than that. If you're using it in some way to assist in launching your rocket, selling a widget kind of pales in comparison to putting it on a launch pad as far as depending on it critically. So that's one of my favorite comparisons to use. But we see it operationally. There's a major cloud provider that uses MikroTik. I can't say who it is, but it rhymes with the largest cloud provider that you know. Hint, hint. And it's, you'll find it all over the place. People just don't talk about it because as enterprises have gotten used to consuming things that are open source, that are commodity, which Linux helped pave the way for, they've opened their mind to being able to do this in a different way and not always needing to run to Cisco and Juniper. Now, does that mean the sky is falling for Cisco and Juniper? Certainly not. They're always going to have a position there. But I would say, look at what Kroger did. Kroger they didn't use MikroTik, but they hired a DevOps team, went out and got x86 boxes. They like ripped all of their routers or Cisco routers out of their stores, and they built their own routers. And they built this really agile ecosystem that they could do whatever they wanted to, that was tailor-made just for what they needed to do. Built their own SD-WAN solution. I think it was out of WireGuard. There's a good talk on it, but I say all that to say Kroger was in a position when the pandemic hit to be able to compete against Amazon as a grocer retailer to do remote deliveries, because they did this agile data center and ecosystem for a delivery. And so, that kind of opened the idea that it doesn't have to be a vertically integrated solution in a major enterprise in a Fortune 100 or Fortune 50 to be able to be mission critical and to work. And I put MikroTik in that because we use it every single day. Now, to answer the second part of the question, which is where are we with routerOS version 7? routerOS version 7 has gotten a lot of stability since the early part of the year. We're starting to use it in some ISPs and some smaller businesses and enterprises because they can't get anything else. The other thing that's driven adoption here is that people can't find routers. People are like, scraping eBay for routers because it's so hard to get gear. So we've seen a lot of enterprises just go out and buy MikroTiks when they never would before, because it's actually on the shelf and they can buy it. Our clients that use Cisco and Juniper, we had one Cisco quote that was like over 2 years. Like they were projecting like 2025 or something insane for some kind of an ASR router. So I say all that to say, it's definitely still a challenge when you're trying to justify it. There's a lot of things you have to navigate, but I feel like the environment is definitely changing to get commodity solutions like MikroTik, like Whitebox, like open source solutions into these large enterprises, because we've done it and are doing it. And if you understand how to make the value proposition to that enterprise, they will typically at least do a proof of concept and hear you out, because the CapEx difference is just too steep to ignore when you can save 80 and 90% on, CapEx for a large enterprise for using something like this.
Yeah, and just to add to that, going back to kind of what we've always said about MikroTik, right? It's kind of the right tool, right design. It's got to match, right? You can't just come at it with, is this going to replace XYZ? You got to align the design to what MikroTik does well and make those choices.
And I think that's one of the things I may have not mentioned when we first started the podcast, is that in the last 10 years, we got ourselves in the position of being MikroTik's largest consulting firm globally, because we've got people all over the world. We've got offices and data centers all over the world, and we cover a lot of time zones. And the way that we did that was by being realistic about what MikroTik's limitations are. We're the biggest MikroTik probably fanboys that you're going to find that are realistic. I think, the customers would say, hey, can I use the MikroTik for that? I'd say, you know what? I probably wouldn't use it for that. That's not a great use of what it does well. I would use this other tool or this other thing. And then I go back to MikroTik and say, hey, people are asking for this. If you implemented this and it could do this well, it would probably give you a more complete solution. So, we'll say, hey, go use this, but we'll also feed that data back to MikroTik, because, MikroTik is just, a very unique solution. Nothing else really, comes close in the space. So, but you do have to be realistic about what the limits are. And if your requirements are beyond the limits of the box, then you should probably choose a different solution, which is the other reason why, as a firm, we don't sell anything. We don't sell hardware. We don't sell software. We're purely an independent consultant, because we're all about the design, so that we are a bit neutral in that perspective of what to recommend, which we obviously love MikroTik, but sometimes we recommend other things because it's the right choice for the design.
Cool. Yeah. The other question that we've had come up quite a bit today with regard to routerOS 7 is there's a lot of people that are trying to run it on the early 2004s. I know had some issues in the beginning that were maybe unrelated to routerOS 7. And then there's also the 1072s that are capable of running routerOS 7, and people are burned. What's your general take? I mean, should we even try to run routerOS 7 on some of these older generation models, or should we only judge it based on new and forward upcoming models?
So that's a really interesting question, because it's one that we're constantly asking ourselves should we be doing this? There's a couple parts to that question. The first part is understand and recognize that, Telera is a dead architecture. They're really not manufacturing it anymore, except for, I think MikroTik is the only vendor consuming Telera. as far as I know. Um, so if memory serves, and Sajin, you could probably say better than I can, but if memory serves, they stopped supporting Tolera in the Linux kernel, and MikroTik, that's one of the things that made V7 take so long, is MikroTik had to go build their own custom kernel and put the drivers in to support Tolera. And because Tolera was kind of, was getting out of popularity, the software development kit just wasn't there the way it is for ARM64 and Marvel Prestera. That's why back in like around 2015, 2016, somewhere in that neighborhood is when they made the decision to move into the ARM chips and the Marvel Prestera stuff, because they knew that, Tolera was not a forward platform. Now, does that mean that you can't run it stable on a Tolera platform? We've got several ISPs that are running V7 as peering routers and as aggregation routers with MPLS, and they seem to be doing fine. I think it's probably going to be another 6 months for us to be able to tell how far forward we can carry the Tolera, CCR 1K series into RouterOS version 7. And that may be a good question to ask MikroTik, because, I don't know that I have all the details underneath in the hardware and how that ties into the version of Linux that, that they had to build to be able to support Tolera, and what the expected lifespan of that is. I mean, MikroTik always tries to keep gear running as long as they possibly can, way beyond anything else. So I would expect that they're going to try to stretch Tolera out until the end of the decade, if it's possible. And then if it's not possible, they probably are going to put a note out about it. And that's my best guess. But so far, it seems to be working without problems that I've seen when you put V7 on the Tolera platform.
Cool. We've got one more kind of question, then we can probably start closing out. Over time, as new models come about, we've kind of had our flagship, not so much flagship for MikroTik, but kind of what we would say this is our go-to model in XYZ use case, right? The 1036, for example, has been rock solid in a lot of use cases in various environments. Moving forward with all these new models, or with the 2 series stuff, do you see kind of that changing? What's our most reliable kind of unit that we would start recommending?
I do. I think the one that stands out to me, that seems to be the favorite, is the 2116. The 2116 is kind of the new 1036. It has an ASIC in it. It's relatively inexpensive. In some places, it's even cheaper than a 1036. And so far, they've been pretty stable for me. I run one as my home router. I run one here at the office. We've got clients that are starting to run it as aggregation and border routers. Not to say that you're never going to catch a bug, because we're just too early in the cycle to say that you're never going to hit a bug. But it's to be fair, to level set the playing field, we hit bugs even in really mature platforms and in other vendors all the time. So it's not I think that's the other thing that has driven the enterprise adoption to it, is the software quality, other than a few players, seems to have gone way down in the last few years, which kind of matches the financials of where those companies are moving their money from development into acquisitions and other areas. Software quality of some of the major vendors has gone way down. So I think when people look at that and they say, what's my price per bug, right? If I'm going to have bugs on everything, what's my cost per bug? It's definitely the cheapest on MikroTik. But they're pretty fast about patching bugs now. The MPLS bug that I submitted was a bit harder. I think it took them about 45 days to 60 days to patch that one. But the hardware offloaded NAT bug that I sent in, I think, Sajin, what do we get that? We get that fixed in like a week and a half.
It was a week.
I think that got patched in like a week and a half. So other thing to realize about MikroTik, if you haven't navigated this transition, and I think there's a blog article about it on our website, MikroTik used to not use Jira as their management for ticketing and tracking like a lot of other software developers do, because it's kind of the gold standard in that world. They used to have an internal ticketing system that I think they built that was email based. Now there is an actual web portal that you can go put really detailed information in and see this really nice UI for, but hey, we've been able to replicate the bug. Here's a screenshot. So instead of these emails back and forth, which is what we used to do when you would interact with MikroTik, you have Jira. And if anybody of you've used Jira, not that it's perfect, but from where we were with email based ticketing, it's a lot better, which means MikroTik's much larger development staff now can chew through these a lot faster. So I'm gonna wager and hazard a guess to say that when I was around 10 years ago for the RouterOS version 5 to 6 transition, it took us a couple of years to get to like real stability. And then it took like another 3 or 4 years to really iron out like all the little deep-seated bugs. I think we're going to get there in a much shorter time frame. I think we're going to get to stability in general for most everything, but really, deep corner cases by the first or middle of next year. And when I say that, I mean, not that it's not stable on what it's on, but if you're going to go throw every bell and whistle out there on and flag it on, I think we'll be at that point where you can use most everything in the box and be stable by Q1 or Q2 of 2023. And then if you're doing things that are, that are just, basic peering, routing, OSPF, some natting, firewalling, you're not trying to do, 10,000 firewall rules or trying to do some insanely complex mangle actions. I think most of that's going to work for you right now from what I've seen. It's when you do what we call feature stacking and you take 10 of those things together and combine them in either a really large amount, or you turn on flags on, Mangle or something like that, matching that people rarely use, that you'll start to find those bugs that, haven't been tested in interop. So, be mindful of that, the mainstream use cases tend to be more stable. And most of the development has been on the rack mounted CCR2K, RB 5009. Other thing to realize is if you go use an older router, if you go use, some older HAP router or an RB 900 or something like that, you may find that there's a bug or something that doesn't work because not as many people are testing version 7 on that as they are on these newer CCR2K, CRS 300 and 500 platforms. So to be aware of that, the newer platforms and the CCR Tolera series, and the ARM-based series of like the 1100s and the RB 4011s, that's where I see almost all of the chatter around these. The only exception to that is in the home user crowd, and now the AX has come out, Wi-Fi Wave 2 and the AX standards come out, a lot of the HAP series and the AP series that are out, people that are using this for home, small business, and those kind of use cases are testing a lot of the smaller boxes around that. So that's generally where the pool of usage and testing is coming in. And if the router boards you're using are more obscure, definitely put that on the bench and test it because, you may find some bugs that you need to send to MikroTik.
Yeah, you definitely triggered anybody in software development when you said Jira is great. But yes, definitely for this use
comparatively, you have to understand where we were. That's like going from a stone wheel that had 4 sides to like having an inflatable tire. So if you're a high-end software developer and Jira is not, not perfect, but compared to where we were, we're like light years ahead of MikroTik's ability. So yeah, apologies to the.
No, it does create a way better experience for getting support, submitting things. Yeah. One thing I wanted to make a comment on with regard to software quality, I do think that that's a larger trend amongst all software developers over the past 10 years. I think, we've kind of taken a shift from in over a decade ago where you would write a piece of software to be tested, it would be concise, and then it would ship. And this idea that you could update it was not really a mentality, that you can update things once they're out the door was not really a mentality. So like the agile nature of software development today, I think has pros and cons, but a lot of those cons are kind of what you were mentioning, which, hey, like every company's quality is degrading because developer mentality, this is a completely separate topic, but developer mentality is very much like, hey, let's just keep pumping code out every day, right? And if a bug comes in, I'll fix it tomorrow. And then that's kind of it's a gross exaggeration, but that is a mentality that's kind of seeping in across the board. And we see that with MikroTik too. Like, look at their release cycle, right? Like, you look at how many releases they put out just this year compared to the past, 10 years trending. It's been staggering.
Oh, it's been huge. I mean, if you're to put, I would love to put it on a graph because I said that the other day. If you put this on a graph, you would probably see this massive peak in the last 18 months, and really even in the last 6 months of, pretty much every week or 2 weeks, we're churning out code, which is fantastic because in another year at this pace, we're going to get to a point where, you've got a router that can go toe to toe with a lot of things out there. That's going to be mature. It's going to be stable. It's going to have a supported hardware ecosystem on the ARM64 and Marvel side that's going to be around for an incredibly long time. So the future is very bright for MikroTik, especially going into, if you look at all the things going on in the global economy, potential recession, war, all these things, not that we need to get into that, but you look at the way enterprises look at this and the way that people are buying network gear, looking at it, they're saying, I may not have $500,000 to spend in the next 2 or 3 years on a router because of what's going on, or in the energy crisis. I may not be able to put a big iron box that's going to go, suck however many, kilowatts down in my data center. I may need to put something out that is SIPs power. I may need to use solar or use alternative energy to put this out. And instead of making that my backup, that might be my primary. I know a lot of ISPs that are starting to go things like, solar and other alternative energies as primary instead of street power. And I would say I have no hesitation about saying MikroTik is probably the best router to put on solar and any other kind of alternative energy, hands down. I've never seen anything that's as power efficient as MikroTik out there. So as we deal with energy problems globally, I think there is a space for MikroTik to expand into filling that, because you have a 100 gig router. It can push 100 gig in an ASIC and it draws 33 watts. There's nothing even on the drawing boards of anybody else in the world out there that can do that. And it hasn't really been a huge need for it until now, but I think that's about to change. So this is going to solve some interesting problems for people that may not even ever hear about, where you're going to see MikroTik 100 gig routers go into places that they might have never been in before, just because they can do a job that there's nothing else out there to do it.
Well, that's just it, right? So traditionally, there was kind of this graduating scale where, it's easy to start with MikroTik. And then once you hit a certain throughput or feature limitation, you kind of would have to have, historically, you have had to have looked at other vendors. But we're reaching a point where there's certain economies whose connectivity needs are far outpacing the growth of their economy and their budgets. And MikroTik being able to, serve those same economies with 100 gig devices is going to be a really good play for them.
Yeah, I mean, they're already heavily used. If you look at economies where, if you look at the currency as compared to the US dollar and the euro, Indonesia is largely connected by MikroTik. The ISPs use
Mm-hmm.
MikroTik heavily in Indonesia, in India, in Africa, in South America, even here in the rural US and rural Europe, European countries in those areas. MikroTik is heavily favored just because the cost structure of that to deliver that bandwidth is there. So I think there's a growing trend in being able to use it, and in the ISPs that MikroTik doesn't have the protocols, the connectivity, speeds that we want. We'll often pair it with other gear like white box, put white box equipment out in the 400 gig space, and then bolt on the MikroTik 100 gig routers as BNGs or as aggregators or as NAT gateways. So there's a wealth of opportunities. Not just, it doesn't have to be an all MikroTik network. It can mix and match and play into a larger ecosystem of things that, you can build some solutions that are, were unthinkable for the price point just even 4 or 5 years ago.
Cool. Well, Kevin, any last words or?
No, I all I would say is, when wrapping up, this is just the tip of the iceberg. We have a huge lab, not just here, but globally. We're always testing, not only just internally because we're geeks and we want to see what it'll do, but we have a really close relationship with MikroTik. We send them feedback, on things that we find or opinions that we have about things that are going on. We also talk to some of their partners like Zero Tier. We're very active in the communities that they're in, trying to figure out where are these solutions needed. What do we need to do with them? So we're going to keep testing and doing more of these webinars and getting deeper into topics. So if you have opinions on which topics we should deep dive into, and more specifically, what areas of those protocols or what things would you like to see, we'll take that feedback and start structuring the next set of deep dives that we're going to do with the lab work that we're doing. And we can, queue that lab work up, because it takes a while. It usually takes us, several weeks or even months of lab work to kind of run through all these scenarios to get some of these outputs and validate that, yes, it works, it's repeatable, it's stable, this thing works. So it does take some work in doing that, but we're happy to do it and we love doing it. So look for more, give us feedback on it. I'd say thanks to everybody for joining and hanging in with us for this long. It's been great that we've had this kind of engagement. I saw somebody mention this is like a virtual mom. Yes, we all miss the mom. If anybody that's been to the mom, so this is like your virtual mom replacement until we all get back to the mom. And I hope to see you all there. So thanks for joining, and we'll do this again soon.
Yeah, awesome. Thanks, everybody. Thanks, Kevin.
All right. Have a good day.